Before it ever moves at 300 kilometers per hour, this machine must first survive forces that would destroy almost anything else. Every millimeter of this massive structure is governed by rigid industrial tolerances and automated precision. This factory environment is the origin point for one of the world's most sophisticated transit systems. The structural integrity of the KTX begins with the precision alignment of heavy-gauge steel chassis components. Automated verification systems ensure that every structural bond meets rigid industrial safety tolerances. Foundation of engineered steel is designed to withstand extreme physical forces during high-speed operation. The structural backbone is now fully unified and ready for the integration of the vehicle's primary mechanical assemblies. The Bogie system serves as the critical mechanical interface between the KTX train and the rails, requiring absolute structural precision. Every wheel set undergoes rigorous geometric calibration to ensure stability and passenger comfort at speeds exceeding 300 kilometers per hour. Advanced suspension engineering allows the KTX to navigate rail curvatures while maintaining a perfectly level center of gravity. With the high-performance wheelsets and suspension systems validated, the mechanical core is ready for final integration with the primary train structure. Each panel is meticulously integrated into the structural frame to create a seamless aerodynamic envelope. The KTX propulsion system relies on high-capacity power modules designed for extreme electrical load and thermal stability. Redundant power distribution networks ensure consistent reliability across the entire length of the high-speed train.
Integrated power systems are verified for structural integrity, providing the essential energy backbone for high-speed operation.
The KTX command system is built on a high-density, unified control architecture.
Every electronic component is physically validated within the structural frame to ensure seamless communication across the entire train set.
This digital backbone serves as the intelligence center of the KTX, ready for the final stages of structural and mechanical unification.
High-density thermal insulation is integrated to ensure environmental stability.
Every infrastructure component is engineered for long-term reliability and structural cohesion within the high-speed environment.
The environmental core is now fully integrated, providing the essential infrastructure for internal system protection.
High-performance railway coatings provide a critical aerodynamic shield, protecting the structural shell from extreme environmental friction and corrosion.
The final exterior finish confirms the KTX as a unified high-speed rail system.
Every mechanical system undergoes rigorous static verification to ensure operational reliability and component longevity. Precision sensor arrays monitor thousands of mechanical data points to validate the integrity of the primary safety systems.
With all functional mechanics verified, the KTX trainset is officially certified as structurally and technically ready for service. This mechanical marriage synchronizes the 20-ton car body with its traction and suspension assemblies. Structural and mechanical systems are now integrated into a single unified entity.
From controlled factory precision to real-world performance, the KTX transforms engineering discipline into high-speed reality. NextGen Machine Works, building the impossible. Subscribe to join the future.